All right, welcome back. Today we are going to be working on notes 9.3b, where we are going to be solving logarithmic equations. So we've solved exponentials, and one of the things that we talked about with exponential functions was if the bases were equal, then we made the powers equal to each other. Well, if that one-to-one property works for exponentials, right? So back when we were doing exponentials, we said if 2 to the x is equal to 2 to the power of 5, well, then by force, x has to equal 5. We worked with the powers only. We kind of ignored the bases. We just brought them out. So this was called the one-to-one property. If equality exists, well, then the powers should be equal. Well, we're going to use the same idea with logarithms. But the first thing it does say is you need to make sure that if you're able to condense a logarithm, then you need to make sure you condense it. Meaning we only want to have one log on each side. So that's the first thing. We have to have one log on each side. Then it says, okay, once you do that, you can now use the one-to-one property here. And when you're using the one-to-one property, it says, when you have a log base b and a log base b. So the first thing you have to notice there is it's got to be the same base. We have to have the same base for both. If not, this doesn't work. So they must have the same base. In fact, let's zoom in right here. And then it says, so if this happens, then your m is equal to your n. And that's the one-to-one property that we're going to use today. If you have one log on each side and they're both the same base, the only way equality can exist is if you make the m equal to the n. So the insides of the logs need to be equal to each other. Now, it does say afterwards that you have to solve. But one of the biggest things that we have to be careful with today is you have to check for extraneous solutions. Remember, we just saw the graph of a logarithm. When you look at the graph of a logarithm, one of the things we mentioned was we are not allowed to take the logs of negative numbers. So it's kind of a domain restriction, which means if you're not allowed to take the log of negative numbers, you're going to have to check extraneous solutions, right? This is when you get an answer that even though you do all the work for it, it may not work at the end because of the domain. The domain says you can't take logs of negative numbers. So that's what we're going to watch out for. When I plug in my answer, and that's why we use a calculator to do that for ourselves, we just want to make sure we're not accidentally taking a log of a negative number. If we do, then that answer has to get thrown out. But we're going to be checking our answer as we go. So again, the biggest thing is we're going to have one log on each side. So condensing, I'm going to use that rule. The one-to-one property means they have to have the same base. Well, then I drop the base and I make these equal to each other. And then I just solve, but again, you do have to watch out. This is only the third time in math that we have to be careful with a domain where you can't take logs of negative numbers. We're not going to use this box, so feel free to use it to write that in there. All right, so let's begin. So let's see. When I look at this problem, yes, here's the equal sign right here. And so I look and it says one log on this side, one log on that side. They both have a base 5. Okay, so we're good. Well, then I get to use the one-to-one property. The one-to-one property says if you have logs with the same base, then make the log value, right, whatever's inside the log, bring them out. That 5x plus 9 has to equal 6x. And then I just do some basic solving, subtract the 5x. See, they start you off with an easy one here. 9 is equal to x. There we go. Now, here's how you run a quick check, and this is where that before I check this out and say, yes, this works, you can bring in a calculator if you need it. See, you're going to plug it in. So I'll only write this once, just for this one here. So it says the log base 5 of 5 times 9 plus 9. Notice that means you're going to take the log 5 times 9 is 45. 45 plus 9 is 54. But you know what? I'm good there. Why? Because it's a positive number. That's really all I'm worried about. And then when I do it over here, it says the log base 5 of 6 times 9. And it says, well, that's the log base 5 of 54. You see, I don't need to finish the problem. I'm okay there. The fact that they're both positive 54s, well, one, it matches, so we know it definitely works. This answer has been checked. But in reality, all I'm worried about is just make sure there's no negative in here. As soon as you say a negative in here, forget it. That answer's out. Shouldn't work. All right, this one here is very similar, so that's why we're going to jump down to these two here. All right, I have a log, base 9, base 9. Okay, we're good. So that means if I want equality to continue, then all I have to do is drop the logs and make these two equal to each other. So pretty straightforward. 6 minus 3w is equal to negative 2w. I'll add the 3w to both sides. I end up with 6 is equal to w. And so we're saying, hey, cool, I got my answer. But remember, let's run a quick check. So I'm going to try it out on the first one. Log base 9 of 6 minus 3 times 6. That's log base 9 of, if you throw this in a calculator, negative 3 times 6 is negative 18. Minus 6 or plus 6 is negative 12. That right there, I'm going to stop already. We're definitely stopping there. Why? There's a negative. I don't even want to check the other side. This one already failed. Because we have a negative, remember, you can't take logs of negatives. So then we cross this out, but I have to give them an answer. They said solve it, so I'm going to say no solution. We are not allowed to take logs of negative numbers. We said that earlier, and this is where it shows up for the very first time. So this is my answer, no solution. This is what we call an extraneous, because of that negative right there that came up. Again, I didn't even have to test it on the other side. As soon as this side failed, it was over. No logs of negative numbers are allowed. Okay? All right, now I wanted to choose number 4 for a reason. Yes, there is the base 10. Don't forget it's invisible. That's a base 10. That's a base 10. The problem here, though, is to start it off, is this side. We have 2 logs. We're not allowed to have 2 logs if we're going to use the one-to-one property. I want only 1. But that's why we learned how to condense the other day, where we said, if you have 2 logs with the same base, then turn it into 1. But remember, because there's a plus sign, the question is, what will I do with these 2? Well, there's the 4, there's the y plus 5, and then just remember, because of the plus sign, that just means one thing: multiply. And it's equal to the log of 72. So a little multiplication will take place there. And now we do have 1 log. We do have another, which means we are going to make this equal to that, because that's the only way the 2 logs can remain equal to each other. So 4y plus 5, I should have probably distributed already, 72. So here we go with the distribution. 4y plus 4 times 5 is 20, is equal to 72. Subtract your 20. 4y is equal to 52. And when I divide by 4, low on space here, y is equal to 13. But before I can make it official, let's do a quick check. So here's how I like running my quick check. I'm going to put a 13 in there. 13 plus 5, that's positive. I'm good there. I can't plug in there. That's already positive. That's already positive. So you see, I got no negative in here. Since it was positive, then we're good. We know it should work itself out. All right, let's try 3 more here. I know there's 8, but let's try these. There's something kind of interesting on each one. Now, on this one, you might look at it and say, oh, it's ready. I've got a log base 7 and a log base 7. I have one log on each side, but it's not ready because of the number 3 in front. Remember what we said. When we're condensing, even a number in front doesn't work for us, but just remember it becomes a power for the 4 to the third. So in reality, this thing says log base 7 of 4 to the third is equal to log base 7 of 4a minus 8. See, now we're ready. No number in front, right? No leading coefficient. So then we're ready. Now I'm going to make this, which I'm going to work out, of course, equal to this. So 4 to the power of 3. So 4 times 4 times 4 is 64 is equal to, remember, we're dropping the logs already, 4a minus 8. All right, here we go. Add the 8 to both sides. So 64 plus 8 is 72 is equal to 4a. And then we divide by 4, divide by 4. A is equal to 18, but we'll run a quick check right now. Remember what our quick check is. Remember, you have all this space, add little notes to yourself, especially when it comes to those quick checks. Or you could just check here on the side. It's up to you. You have plenty of space there. All right, 18. Well, there's no X there, or A for this one. All right, here's where I have to check. 4 times 18. Let's see, 4 times 18 minus 8. So minus 8. And look at that, we got a positive number there. So because we have a positive number, we're good to go with that answer. But we do have to run a check for it. Okay. Now, here on this one, don't forget, when you do bring this together, here's the only thing I'll say. Log base 4, remember, it is a minus sign, so that means a fraction. 68 over 4, and then I would reduce that, of course. That does divide nicely before you do anything else. So just want to mention that when it's a minus sign, it means it's a fraction. But I didn't want to go over that one, but I do want to mention about the minus sign becoming a division. This is the one I'm concerned about here. Yes, there's a number in the front, so I'm going to send it back up. So it says log base 6 of 25 to the power of 1/2 is equal to log base 6 of 23 minus 4w. Remember, a power of 1/2 means it used to be a radical. So when I bring this down, I'm going to write it as the radical or square root of 25 is equal to 23 minus 4w. Remember, we are allowed to drop those logs already. So when I have this, well, then all I have to do is just take square root. And just like that, I'm ready to complete the problem. Let's see if this is going to be one that works out. Subtract the 23. So I get negative 18. Oh, we see negatives coming. Negative 4w. So I'm going to divide by negative 4. All right, so the negative is gone. It was a little bit of concern at first because it could lead. Doesn't mean it can't be negative here. The answers could be a negative. 9 over 2. I'm going to reduce it. Just so you know, if you get a negative answer here, it could still work, but you have to check it. All right, here we go. Let's see. 9 over 2. So 9 divided by 2 is 4.5 times 4 is 18, and 23, take away 18. All right, we're good. Look, it's a positive number. That's all I was worried about. It is a positive, so we are okay. All right. Now, on this one, the only reason I want to talk to you about that one, and maybe we won't even finish it, but at least just to give it a start. Yeah, this side is fine. Log base 3 of 2p minus 5. But remember, it's asking you to send the 2 back up to a power. It does have a minus sign. So when you write it as 1, the minus sign means it's a fraction. What's after the minus sign? It's the 4. But remember, on top, you're not just writing the 6. You're writing a 6 squared. So just be careful when you're rewriting problems like this on your homework. You're moving it over, right? You're bringing it up to the top. The minus means a fraction, and then there's your 4. So this will end up being, watch, if you look at it on the side, 36 over 4. So notice that's just the log base 3 of 9. All of that just to represent a 9. And then, of course, now you could make them equal to each other. The insides of the logs make them equal to each other, and you can go from there. But I just wanted to show this again. Yes, it's a power. The minus means a fraction. Just take care of the numbers off to the side. Okay? Right, let's flip the page to our last page here for this note. Remember, this is only one method. You're about to learn that there is another. But we're going to do this first here. Now, same rules apply. You might say, oh, it's got a power 2. Yeah, that is a little different, but we've got a log base 4, and look, no condensing. This one is perfect and ready to go. So then I'm going to make m squared equal to 18 minus 7m. Now, you have to remember one thing. You have two m's, and you have a power of 2, making it a quadratic. So don't forget, and this is why we have the space here. For quadratics, first thing, set equal to 0. So I have to make this thing equal to 0. So I'm going to subtract the 18. I'm going to add the 7m. In fact, here, let me do that now. I'm going to add the 7m. But I am also going to subtract the 18. We're just going to try to do it all in one shot here. So minus the 18. So after all of that, we have m squared plus 7m minus 18 is equal to 0. So that's the first thing. And then what do? Factor. Factor is the name of the game when you're working with quadratics, of course. So we have it here. Let's see. Let's get our factors going. M and m. I need numbers that multiply to 18 but subtract to give me a positive 7. Well, then the only numbers that work are a positive 9, because I want a positive number, and a negative 2. Now, of course, I'm going to use the zero product property, which means make each factor equal to 0 and solve. So I make m plus 9 equal to 0. M minus 2 is equal to 0. And just like that, because we're out of space, m is negative 9. And m is equal to positive 2. But the original question had a log in it. We're going to have to check our numbers and make sure they work. All right, so remember, my only concern is I don't want a negative. So I'm going to start with that negative 9. Negative 9 squared is positive 81. Remember, when you're doing the math, you're going like this, in a parentheses. So yeah, that's positive. So I'm okay there. But then when I put that in here, 18 minus 7 times negative 9, well, the negative becomes positive, and then you're going to join it with 18. All of that is positive. Then that one works. So I'm good with keeping the negative 9. That's why I told you earlier. Just because your answer is negative doesn't mean it's completely out. It could still work, and it does. So now I try the 2. Well, 2 squared is positive. 2 times 7 is 14. 18 take away 14 continues to be positive, which means, well, that one also works. So then this one has 2 possible answers. Remember, the concern is not getting a negative inside of a log, and we were good for both. All right, so for number 10, it's very similar. Same idea for number 10. We see a quadratic, but the only thing you have to watch out for is they did give you 2 logs on this side, so we have to do a little condensing. So I won't finish it, but I will show you that for this one, you would say log of, well, remember, there's a 2, there's a k squared, but because there's a plus, well, we already know that means multiply. So it's just 2k squared is equal to log of k squared plus 16. You know what? Maybe we will finish this one. See, one log. Then I'm going to make this equal to this. The only reason I'm bringing it up is I just noticed that there is no regular k here, just k squares. So when I subtract my k squared, because you should join them first, then I get k squared is equal to 16. Remember, we do have the option here. Yes, I can factor. I can move the 16 over. It could do a couple things. Or we are allowed to take square roots because there is no extra k anywhere. But my only concern here is too many people do this. They go k is equal to 4, and that is completely wrong. You have two possible answers. That's why factoring works better. When you factor, you're supposed to end up with two k's, just like here I ended up with two m's. That's why we have to remember the plus or minus. Now I kind of put both of them in one. Let's make sure they both work. Positive 4, yep, that's still positive. Anything to the power of 2 is positive. So yeah, they're both going to work, because even if you throw a negative in there, remember when you square it, it becomes a positive. So that's technique number 1, using the one-to-one property. So the question is, well, what do you do when you don't have logs on both sides? And so here is the last idea for the day. It says condense, all right, so one log only, and isolate the logarithm. So just make sure that you have a logarithm on one side of the equals. Write the equation in exponential form. What they're saying here is, well, use our circle method, right? If it's a log, use the circle method to change it back to an exponential. And then once you do that, since it's an exponential, we'll do what we did with exponentials. Just solve it. Watch out for extraneous. You still have to check for that because the original question still has a log. So let's apply these rules here. See how it goes. Log base 2 of x minus 4. Let me cover this side up. See, there's only one log. This is isolation. If you're worried about, yeah, but don't you have to get rid of the 4? Remember, the 4 is stuck. It's stuck inside the log, so we can't do anything with it, which means I'm ready for step number 2. Step number 2 says, take the log, start at the base, go to the other side of the equals, and then come back. So now my log says this, or it's no longer going to be a log. It says 2 to the power of 6 is equal to x minus 4. See, no more log. We turned it exponential. Well, this is just a regular number, so we can work that out. 2 to the 6 is just 64, is equal to x minus 4. And look, I'm down to one last step. Just add the 4. It's what we were doing with the finding the x-intercepts earlier. Same idea. All right, but we're going to do a quick check. Don't forget, we have to check it. I'm going to plug in a 68. 68 minus 4. That is definitely a positive number. We are good. That's all we care about. Okay. Now I want to mention number 12 because it does have something a little bit different on this one. It says log base 3 of 4x plus 8 minus 7 is equal to negative 3. Yes, there's only one log. No condensing needed. But isolation, you see, if I do this, what we have to understand is over here it was ready. Why? Because all of that was in the log. So here's the log, but notice the 7 isn't part of it. That's what they mean by isolation. They want you to get the log all by itself. So then the first thing and the first step I should take is I should add the 7. Isolation of the log. Again, you cannot use the circle method until the log, its base and its value here, are completely by itself. See, on this side, negative 3 and 7 is now a 4. But again, I could not use the circle method earlier because that 7 was messing it up. Now, is it isolated? Yeah. You can't get rid of the 8. You can't get rid of the 4. It's stuck inside. Well, then let's get it out of there. And the only way to get it out is to use our circle method where I start at the base, go to the other side of the equals, and then I come back over here to the log. So it says 3 to the power of 4 is equal to 4x plus 8. See, circle method, no more log after that. All right, well, let's continue to work this thing out. 3 times 3 times 3 times 3 is 81, is equal to 4x plus 8. Let's get rid of the 8, of course. A little subtraction there. So we have 73 is equal to 4x, and then we divide by 4. Now, this one doesn't divide nicely, but that's okay. 73 over 4. We can just leave it like that. We got to run a quick check though. See, if I plug in a 73 over 4, you can use a calculator, but look, you're plugging in a positive number. You're multiplying it by 4, so it's still positive. And then you're going to add an 8. Well, that makes it more positive. Then we're good. This definitely passes the test. But you can use a calculator to make sure. We just want to make sure the inside is always positive. Okay. And then on to number 13. I'm going to do 2 more of these. The others are very similar to what you've already done, so we're not going to spend too much time on them. All right, so here we go. Number 13. Now, for number 13, we have 2 logs. Okay, that's a problem. Now you might say, well, just move it over to the other side and you could do what you did earlier. But there's already a number out there. That's why this rule is for when you have a log and it equals a number. So something on the side. All right, well, we already know what to do here. We were told to condense it. I'm going to take those 2 logs and just write it once. So here it is, log. And then, of course, I'm going to take the insides, 2x and x minus 5. But because there's a plus sign, don't forget, that's 2x times x minus 5. And yeah, out here, there's just a 2, but that's me condensing. Well, let me finish condensing it, make it nice and clear. Remember, there's an invisible 10. I might need that afterwards. 2x times x is 2x squared, and 2x times negative 5 is negative 10x. And it equals 2. All right, there it is, the distribution. So now it's ready for me to write it as an exponential. So we're going to go this way here. All right, 10 to the power of 2 is equal to 2x squared minus 10x. This, of course, is 100, is equal to 2x squared minus 10x. All right, let's keep it going. It is a quadratic, so like we mentioned earlier, we have to set it equal to 0. So I'm going to subtract my 100. All right, so there it is. 0 is equal to 2x squared minus 10x minus 10. Now, we are going to ignore this problem. That's going to give us more space, so feel free to cross that out. We'll do one of the others after. Now, we notice that a 2 actually can reduce all of these numbers. Sorry, it's a 100 there. So I am going to take out the GCF, which is a 2, leaving me with x squared minus 5x minus 50. Remember, GCF is always the first step in factoring. Now we can factor. Get my 2 parentheses going here. All right, so we're looking for 2 numbers. One, they're going to multiply to get me a 50, but they're going to subtract to give me a negative 5. So the only numbers that multiply to 50 and subtract to a 5 are 10 and 5. And because I want a negative number, then the bigger number should be negative. All right, so here we go. Now we're there. At this point, sorry, should have moved it earlier. But now I set my factors equal to 0. X minus 10 equals 0. X plus 5 equals 0. So x is equal to 10 and x is equal to negative 5. But we have to check our answers. We don't want to take a log of a negative by accident. And when we say that we're going to check our answers, we're going back to the original. That's where we have to check. So let's start with the 10. When I plug in a 10 here, 2 times 10 is 20. That's positive. We're okay. And then when I take the 10 and I subtract 5, well, 10 minus 5 is positive 5. Everything was positive. This one checks out. All right, we got a negative. Now, that doesn't make it an automatic no, but let's test it out. I've got a negative 5. 2 times negative 5 is negative 10. You see, look at that. When I'm checking it, 2 times negative 5 is log of negative 10. There you go. That's not going to happen. That should not be happening. We can't have a negative. So what does that mean? I cross it out. Now, the mistake people make is they go, oh, you cross it out, so it's no solution. No, there is a solution. It's just a 10, not this one. All right. All right, here we go. Like I said, the rest are Pretty self-explanatory. So we'll do number 14 in case we need the space here. This one is very much like the one we just did. Look, pretty much the same. You're going to do a little multiplication, except it equals a 1, so the numbers will be nice and small. All right, so let's do number 14. 1, I want to do it because there's a number in front, so I got to send it out up there. So because I'm going to use the space below, I'm going to take my time with this one. So it's log of x squared minus the log of 4 is equal to 10. Okay, that's the first thing I did. Now, they both have the same base, so I'm going to write the word log once. But because there's a minus, there's my fraction. But what's in front of the minus? X squared, so that's on top. What's behind the minus? Well, the 4. There's the 4, and it equals 10. So now I'm ready to use the circle method to rewrite. Now, don't forget, there's an invisible 10. So here we go. And now it says 10 to the power of 10 is equal to, wait, where'd I get a 10 from? Sorry, fix it here. Just noticed there is a 2 there, not a 10. Sorry for that. There's a 2. Not sure why I changed it. All right, now the number isn't ridiculous. Okay, 10 squared is equal to x squared over 4. All right, let's just keep working it out. 10 squared is 100, is equal to x squared over 4. How do you get rid of division? Well, of course, you do a little multiplication. I'll multiply by 4. We'll do that. So 400 is equal to x squared. Now, again, this is what I mentioned earlier. So feel free to throw out this 16 right here because it's just the same thing we did on the other side over here. We need the space. We are now ready, of course, to take a square root. But you have to understand that when you take a square root, you have 2 possible answers. X is equal to plus or minus. Square root of 400 is 20. So I do need to check them both, positive 20 and negative 20. Factoring avoids you trying to remember this little rule, but this is faster. You can't forget that plus or minus. All right, here we go. We're going to check the 20. Plug in a 20. Remember, I'm plugging in right here. Actually, that's the only place. Look at that. When you look at the original question, that's the only x there is. There is nowhere else for you to plug it in. So if I plug in a positive 20, then I'm okay because positive 20, I can take the log of that. But if you plug in a negative 20, see, that's not going to work. And you might say, but as a 2 in front, doesn't matter. You got to go back to the original equation. Plugging in a negative 20 would fail. So then this one doesn't count as an answer. It's extraneous, but this one worked. So please be very careful today with extraneous solutions. And remember, when you're working with quadratics, yes, you could do some factoring, but if you only have one x involved with a power of 2, yeah, feel free to use the square roots, but you can't forget that plus or minus. Make a note to yourself. All right, with that said, you now have all the information you need for today's homework. Have a wonderful day, everybody.